The next module is model management. And as I mentioned, the kind of distinction between users and administrators and customizers is sometimes a little blurred. But we'll talk about subjects that are important for every user, really, and certainly for management and product leads. So we have a tab really where most of the model management functions are grouped together, the Manage tab. And we can look at some of the functions we have there: versioning models, creating a sandbox or a branch of a model, rebase, reconcile, profiles, export import, cloning capabilities, creating replicas, differencing, reporting, and then deleting model families and model versions. So we can see the same types of information and the same types of functions in Model Explorer. So as mentioned, that's a standalone app for managing models. We have a command line interface, SCF utils. So this can be used to run lots of our administration model management type functions. And this is obviously well documented and commonly used to automate certain tasks. Mentioned earlier the Model Manager app, which is a web tool that you can use to do model management administration type capabilities. And this is beneficial because it means you can do it remotely and don't have to access the physical server machine to run these operations. Mentioned profiles earlier, and again, profiles are a UML mechanism for extending a solution. So we see when we create models that generally they'll have profiles in there. And you can see we have a SysML profile. When you select that, it will automatically select the UML profile because that's what it's based upon. There's a utilities profile that provides additional capabilities, behavior. There are profiles for simulation, SciSim, profiles for code generation, the ACS profile, and as mentioned, ThingWorks. So each of these provides a different data model and different capabilities, and typically they can all be added in and used at the same time. So you're kind of having all of the capabilities and all of the meta model. And you can customize these profiles as well. So a lot of our customers that want specific types of entities, specific relationships, diagram types, names, they can create custom profiles. They can use scripting to add custom behavior, and then they can always use those profiles with that behavior when they create models, and may not ever really use the standard out-of-the-box profiles, SysML, UML, and so on. But generally, they'll be extending them, building on top of the existing profiles. That's the easiest way to create custom solutions. Quite a few of the entities that are in there can be reused in a more generic way. The class and the block being one example. Use cases can represent functions in a more generic sense quite easily as well. So this is a good approach for a lot of customers that want a more custom meta model specifically for their types of entities. Okay, so we mentioned access permissions. When we implemented and designed Modeler, initially the intent was to try and keep administration as low as possible. Modeler is a design authoring tool, similar to a CAD tool, essentially, in that you're creating design models. So it's really a desktop application rather than an enterprise level system. And we didn't want to have to burden users with too much administration. But we do have access permissions. These are applied at database level. initially. So we can see in the graphic that we can right click on a database and look at the access permissions. They can grant global permissions, read or write. And that will apply to all models in that database. So you can grant no permissions at the database level, and then access permissions of each model can then be determined at each model level. So if you don't want to have global policies, then don't define them at the database level, define them at the model level. So here we see access permissions defined at the model level, and we can do this through Model Explorer or through Modeler itself. So the graphic in the middle is actually inside Modeler. We've selected a package and we're managing the access permissions at that package level. So it's that granular, not down to the individual item level like we have in other tools from BTC, but we can define permissions at the database level, the model level, and then at the package level. We also have the notion of protection. So this is similar to access permission. Basically, it just locks down any edits for that item. And this is a typical or a well-established notion from software development world to protect your software development designs brought forward into Modeler. And we can see we can copy that protected flag to child packages. So it's very useful when you want to lock down a design and quickly and easily set permissions across within a particular package and then propagate it down to all child packages. Some important concepts to understand. Again, to contrast with, say, Windchill PLM, which some of us may well know that Windchill PLM manages versions on individual parts and individual items. So a document or a part can have multiple versions. Windchill Modeler, on the other hand, manages its versions at the model level. It's no more granular than that. It's just at the model level. So we can see in our graphic, Model XYZ has version 0, version 1, version 2. And then, of course, as you create new versions, they'll go to 3, 4, 5, and so on. So a version is a way of really snapshotting or baselining the previous version. As you create a new version, the previous version becomes protected. You can unprotect it if you want to modify it, but the default behavior is to protect it, and we can see in the graphic at the bottom, version 2 is not protected, so this is the live model version. Version 0 and 1 have been protected and are essentially locked to edit. So versions become that significant milestone, really. Users can create versions to represent the phases of development that they want to. Some customers create quite a lot of versions of their models, and some only do it at certain specific milestones. This is how we actually do it within the system. So through Model Explorer, we right click on a model and then choose new version. Or we can actually do it from within Modeler itself, from the Manage tab, choose version model. Okay, the next concept that we need to understand are private sandboxes or branches. The design intent here is to provide a way to make changes to a model in isolation from the master. So again, it's conceptually similar to software code management systems. So we create a sandbox of model version 2, and it creates a copy of the model, version 2.0.0, and this is private to the user that created it. You can change the permissions and give other users access if you wish, but the default behavior is that that's a private model for that user to modify. You can do it through Model Explorer, as shown here. Right-click on the item, New Private Sandbox. So this helps us with concurrent and parallel model development. It means that multiple engineers can take copies of the model and work on individual parts of it in isolation. They could work on the master at the same time, or they might not want to do that. They might want to actually have their own sandbox to work on. And then, as you'll see in a moment, the next step is to kind of merge that back in to the master. So it can support parallel development. It can help to isolate model development, which is useful for code generation. So when you're building code, you don't want anything to affect the generation process. So it helps to isolate your model for just that. It can be a good way of enforcing review processes. So before major changes are actually put onto the master, you can ensure that they're in a sandbox where they can be reviewed carefully before you try to merge and reconcile. It helps with offline and remote working. A user can create a sandbox and then copy some of that to another model and then copy it to another instance of modeler on another machine and then work with it there and then bring it back. Can also help with design variants, working with product line engineering. So once we've created some versions and then created a sandbox and our users made some changes in that sandbox model, we can then reconcile it. And this is a merge, essentially. So the changes that were made in that sandbox can then be pushed to the master model. And that then becomes the latest or the tip version of the trunk. If there are any conflicts or clashes, so if there have been changes of the same item in both the trunk and the sandbox, then there's a dialog that modeler shows that lets you choose between which change to accept. So it manages any collisions or conflicts during that merge. This is a really powerful capability that we don't tend to offer in data management tools. So this is really powerful capabilities that users can take advantage of and really help them with concurrent engineering and good process and best practice application. Rebasing is essentially pulling the latest version into a private sandbox. So if some changes had been made into the master and you want to bring them into your sandbox, you can use Rebase. So it's an important capability to make sure that as you work on your sandboxes, that you're not working against an older version of the model, which has since changed, because then your sandbox now becomes too far out of sync with the master. Okay, so create a new model, add some packages, create a new version, create a private sandbox, reconcile, observe the model tree in history. Okay, so let's go and demonstrate that. So here's modeler. Start up the Model Explorer and work there for this demo. Okay, so let's go and use the temp. I'll create a new model with profiles. So let's create a SysML model, and I'll choose the SysML full profile. It automatically selects the UML profile for me. Just call this demo 1. So this sets up the necessary schema in the database for SysML to support SysML objects. And as mentioned earlier, it's an extension of the UML profile, so that's why that's added. It uses the kind of notion of aliasing as well in the background to help us assign the relevant type names to different items. So you can do this through Modeler as well. You can create a new model, just the same function here, so you don't need to go into Model Explorer to do this. Okay, there's the new model, and I'll make sure that versions are shown, are displayed. So if I expand this, we'll see the first version. So quickly, let's just create a new version of that. This will create a new version of V1. It may take some time. Well, there's nothing in the model really at the moment, so it won't take too long at all. And then we can see that it's locked the previous version. This is now the active one. If I double click, it will open that model. And we can see we've got those profiles added. So we can add a new package, quickly create a use case diagram, the use case on there. Okay, so close that down. So we've created a new model, we've versioned the model, we've added some model content to it. Now let's create a private sandbox. So I want to work on this in isolation. You see, it's use my name, so it's created testers sandbox of demo 1 v1. And now this is the actual sandbox model. So I can open that. I'm working just in the sandbox, and you can see at the top of Modeler, it tells me that. So I can create another package. Let's create a requirements diagram. Create a single requirement. Close down Modeler. So I've made some changes to my sandbox. I can now reconcile to trunk. So here's the clash detection window. No errors, no warnings were spotted, as we'd expect. So we can see a log. We wish to go and see more of the detail. Now we can see that we've created a new version. It's protected, and this is for security and sort of good data management practice. So we can either unprotect it, or we can create a new version. So now if I open version 3, of course, we'll expect to see those changes we made with package 2 being visible on the requirements diagram. So this is just a basic example of how you manage and interact with model sandboxes and then reconciling back to the trunk. Of course, most of our customers use this capability to help them decompose and do concurrent engineering. And there are some good best practices that we'll cover in a moment that help users to use this in the right way. Yeah, okay. We have the ability to import and export models. So if you want to copy an entire model and move it onto another machine, you can do this quite easily with export and import. It creates a zip file. and can be imported into different versions as well. It's quite resilient for different versions of Modeler. Of course, keep in mind that it's a copy, so you don't want to be creating too many copies of models unless there's a good reason. Cloning creates copies of models to the same database or a different database. So it's equivalent to a save as. We can share components. So back to the reuse question that we had earlier, a structured way of sharing is using these components and the tool called the component sharing wizard. So you pick up a package and it will package up the contents of it, and it will then allow you to create a component that can be then imported into another model. So this is, again, it's like a save as, and it's a copy of a package contents, but it remembers where it's come from and it has the ability to be updated. So as you change the source package, as you make changes, you can re-export it and then re-import it in the other location where it's used. So it's not a dynamic automatic update, but it provides a mechanism where you can keep the data, the designs in sync by re-exporting and re-importing. So we can share packages as well as exporting models. So instead of doing the whole model, we can do this way if it's a slightly less, a more flexible, less rigorous way of doing it. If you want to track and do updates, the component sharing approach is better. To help with this, we have differencing capabilities. So it's important to be able to difference your models. So we can run the model differencer with different versions, with different older versions, with trunks, with branches, or with another model entirely. So this provides a comprehensive report that shows all of the different changes and differences between two models that you can choose. We have reporting capabilities for model families. So when you have multiple versions and you have sandboxes created, and certainly for administrators or the power users, this is an important feature to understand and keep a track of all of the versions and all of the sandboxes. You can often improve performance by reducing the size of your database and deleting unwanted models or model versions. So it's good practice to try and keep your database free from junk and delete items that are no longer needed, unless, of course, you need to keep the history. If you do need to keep the history, you can export it to another location to keep it there, and then only work with the latest versions of items. There's a change management capability. It's quite lightweight. Essentially, you create a change note and then lock down a model. So you enable change, and that basically means that you can only create changes when there's a change note active. And the change note keeps a track of all of the changes that are made. So you can see in this example, I've set a change note active, which means I can then actually make some changes. If you enable change tracking but don't set a change note, the model's protected completely. So it's kind of locked down until you activate a change note, and then that will keep a record of all of the changes that you make. So it's slightly different to some of other PTC's other systems, but it's really a lightweight way of controlling changes to a model. I mentioned briefly earlier that we have the ability to set package states and versions. So we can control the maturity and the version of a package by setting a property. So it's a standard property that we see against packages. We choose the text tab and then we can see the different properties: package state, package version. And this is to give an easy way of managing and understanding maturity of the model design. And then if customers want to use versioning, it's a simple text field. So it's not the same versioning capability that we have at model level. It's really just a text label. So it's quite simple at this point. We may enhance it into the future to provide more sophisticated version management at package level. But at the moment, it's a simple text version that you can input. And we also have a history property as well. So when we make changes, maybe lifecycle state changes from one state to another, or from one version to another, these get tracked in this property. So this has helped Modeler to be more consistent with our other digital thread applications, Windchill RVNS and Windchill PLM, and certainly very useful when we're thinking in terms of digital thread and we have maturity and designs in three systems or more evolving over time. Being able to manage and coordinate the maturity and the states of data, it will be important. So here we can see setting the package state. We choose a package and then choose to change the state. And then we have this UI where we can understand all of the packages and change them all together, all of the nested packages in one go. There's a configuration file where we can configure the different states that are available and the transitions from one state to another. And here's the setting package version, just a simple text field, as mentioned. And really, this is just a label so that you can understand that there is some evolution in the package over time. Okay, so the last few slides are around some best practices. And this is good guidance for people, customers that are adopting Modeler and MBSE. So it's good approach to understand the roles and responsibilities for the different types of admin and management tasks, so that there's clear understanding of model versioning, sandboxing, access permissions, and who's responsible. Of course, establish and regularly test backup procedures. Avoid duplication of data. So when the question of reuse is considered, always try to reduce duplication. It solves problems, but it often creates more problems. Of course, when we duplicate data, there's the risk that it becomes out of date, out of sync, and stale. So we want to avoid that as much as possible. Standardize lifecycle states. So consider the evolutionary states of your designs and try and be consistent across models. Try and be consistent with other tools in the digital thread. Keep access control simple and manageable. It's been designed to be simple for low administration, so don't try and make it too complex, and that way it'll be manageable. Of course, scripting can offer additional capabilities and custom behavior, but be cautious. If not written in the optimum way, they can impact performance. So it's important that people understand the best practices for script writing, and we have training material that we can provide. There's information in the help. Try to avoid creating unnecessary versions or unnecessary sandboxes. It can be easy to result in a situation where you have hundreds of versions and hundreds of sandboxes of a model. You kind of lose track of the overall design evolution. So try and avoid that, only create them when necessary. Version and label models and packages when deliveries or milestones are reached. So don't do it all the time. If you don't need the whole model for things like differencing, then you could export packages in the model or use component sharing. and then delete the file after you've used it. So creating temporary copies that you're going to get rid of is a better approach than copying and duplicating data with too many sandboxes. You can revert to old versions of a model. So you just need to delete the subsequent or the later versions of the model. Then you need to unprotect it, and then you can make that the latest again. So you can create a new writable model from that version. You just need to get rid of and delete the later ones. Okay, so it's good practice to rebase a sandbox before reconciling it. So that way you can test privately in the sandbox before making any merges with the trunk. So you can actually check that things are going to, any conflicts would occur. It's good practice to reconcile and rebase often. Some customers leave it weeks and months to reconcile, and this then creates a bigger job. So if you do it more frequently, it's more often, but the integration, the merging work is much easier. So less chance there's going to be a problem. So it's a trade-off really between working in isolation or regularly integrating. And it's much better, we believe, to regularly integrate as often as you can. So when you've successfully reconciled, as we saw a moment ago, the tip version of the trunk is protected. So for best performance, don't unprotect the tip version, just create a new version of it, like I did in my demonstration a moment ago. Okay, some steps to go through for an exercise, kind of just what I did. And for those that are interested, you can read up on lifecycle states and do some configuration to set the states using this file. So that's explained in the help. Okay, so all of these things that we've covered around model management are very vital concepts for all modeler users to understand. And as customers try and adopt MBSC and Windchill Modeler, they need to define the strategy and the approach for all of these things: user management, access permissions, model hierarchy, package hierarchy, lifecycle states, sandboxing, merging, reconcile, backup. So although we're a design tool that sits on a desktop, there are still quite a few of those enterprise level considerations that you need to think about because it's a multi-user tool, database backend. We're working on master databases with shared data, so we have to be very careful when we perform these kinds of operations. Okay, thanks for your time. That's the end of this module.